See, same topic, simple harmonic motion, and it's example number 3. This is horizontal surface, frictionless, 2 heavy blocks, both sides of this horizontal surface, and a small wooden trolley is placed here. One spring is attached at the left and other is attached at the right. So one end spring with the trolley, other with the each block. So 2 springs. Suppose they are non-identical, mean their spring constant different. So due to this trolley position, there will be some extension. So E1 in the left spring, E2 in the right spring. When the trolley is stationary, we assume that this line is the equilibrium line, mean the reference line. Now, according to the Hooke's law, left side force in the spring is F1, K1, E1, and the right side it is K2, E2. Now, trolley is at rest. Acceleration is 0. So resultant force is 0 here in this situation. So both forces are equal in magnitude, opposite in direction, mean K1, E1 plus minus K2, E2, resultant 0. So we can write K1, E1 is equal to K2, E2. But this trolley is displaced from its equilibrium position. Suppose this is the equilibrium position and it is displaced to the new position, either right or left. So this new position is at the displacement of, suppose, X unit. This side block, this side block. So this spring with spring constant K1 extends more. So its extension, initially a E1, now it becomes X more, and the extension of this spring decreases. So initially it is E2, and now it becomes E2 minus X. And do remember, E2 minus X is still greater than its original length. I mean, there is no compression, just the decrease in the extension. So due to inequilibrium, trolley is held stationary by your force, but when the trolley is released, this side force, which is suppose F1 dash, K1, E1 plus X is greater than this side spring force K2, E2 minus X. When it is released, this side force is greater, this side force is smaller due to larger extension. So the resultant force in this situation will be larger force K1 E1 plus X minus K2 E2 minus X, mean larger minus smaller. Now the resultant force FR is equal to K1 E1 plus X minus K2 E2 and plus K2 X. So we can write FR K1 E1 K1 X K2 E2 plus K2X. Look, these two forces are equal, but opposite in direction. So we can cancel them. Hence, the resultant force is equal to K1X plus K2X, mean X common, K1 plus K2. This is the resultant force when the trolley is released. Now, if the springs are identical, then K1 exactly equal to K2 and they can be represented by K. So in this situation, the resultant force will be K plus K. So resultant force is equal to 2kx. Now we have two situations. One, resultant force is equal to K1 plus K2 into X. And the other, resultant force is equal to 2kx. Non-identical, identical. Now this resultant force is unbalanced. It produces acceleration in the trolley. This force is restoring, so we can write minus sign. So K1 plus K2 into X. Now it can be written as A is equal to minus X K1 K2 over X. Now M. Now spring constant K1 is a constant, K2 is constant, this M is constant, so this whole portion is constant. Then we can write A directly proportional to minus X. When acceleration and displacement directly proportional to each other and opposite in direction, then the oscillation, then the motion is simple harmonic. So theoretically, it is proved that oscillation of the trolley after the release is simple harmonic motion. Okay, but the actual equation for this is A is equal to minus X omega square. So when this equation and this equation compared, A compared with A, X with X, minus with that, instead of omega square, in the upper equation, it is written K1 plus K2 over M, mean in this situation, the omega, the angular frequency, the angular speed omega is equal to under root of K1 plus K2 over M. This is the angular speed of the trolley. Now, this omega can be written as 2 pi f. So under root K1 plus K2 over M, it means F is equal to 1 over 2 pi under root K1 plus K2 over M. So this is the frequency. F is the frequency and omega is angular frequency, which is also known as angular speed. Now, on the other hand, if two springs are identical, then this resultant force is 2kx. It can be written as MA, restoring force, minus 2kx. So A is equal to minus x, 2k over M, k constant, 2 constant, M constant. Again, acceleration directly proportional to minus x. So it's a simple harmonic motion. When two equations are compared, A is equal to minus X omega square and this equation. So omega square is equal to 2k over M. So the angular frequency, angular speed omega is 2k over M under root and omega is 2 pi f. So under root 2k over M, our frequency is equal to 1 over 2 pi 2k over M under root. This is the frequency. Now look at both. Here it's k1 plus k2 over M and here is 2k over M. This is the simple difference. Okay, from both, we can calculate time period because the time period is equal to 1 over frequency. So the reciprocal of this will give you the time period because the time period is 1 over frequency. This is the third example of the simple harmonic motion. Now, move to next, which is number 4 example. This is any liquid, suppose water, and we assume that the density of this liquid is uniform and it's rho. Here is the test tube. Its center of gravity is exactly at the center. When this test tube is placed at the surface of the water, it becomes unbalanced. To make it more stable, some sand is added in the test tube, so its center of gravity is shifted down, so it becomes more stable. So when it is placed at the surface of this liquid, it sinks partially and then float. Now this is the sand. This is the center of the gravity because the center of gravity is shifted towards the load. So now it is in equilibrium. Now two forces are acting. One is the weight from the center of gravity downward, and other is the upthrust of the water. Which water? Displaced by the tube. Look, in this situation, equilibrium, both forces are equal. Weight is mg, and the upthrust we have done in AS, that rho g A into volume. Rho is the density of the liquid, g and area of this displaced. This is rho g into volume. So rho g volume, and the volume of the displaced will be equal to first the area of the tube and then the depth of the tube inside the liquid. This is the displaced liquid volume, so it is AL. So we can write mg weight is equal to rho g AL. When g cancelled, it becomes mass of the tube with sand is rho AL. But we have to oscillate it. So this tube, test tube, is further immersed into the liquid. So the extra immersed depth, extra depth becomes x. Now the weight remains same, but upthrust increases due to increased depth. So the new upthrust is equal to rho GA L plus X. Instead of L, it is L plus X because rho G into volume. So this becomes the new volume of the displaced. So it is made stationary by the extra force. You are exerting this force. Now three forces are acting. Look, one is the weight, other is the upthrust, and third your force. So it is balanced, but when you will release it, this force will disappear. Now the upthrust, new one, it becomes greater than the weight because the weight remains same, but the upthrust increases. So the resultant force at the time of release will be new upthrust minus weight. So the new upthrust is rho GA L plus X minus weight. Look, mg is the weight, which is equal to rho GAL. So it's rho GAL. Now simplify it, rho GAL plus rho GAX minus rho GAL. This cancelled. So the resultant force is equal to rho GAX. This is the resultant force. And the property of the resultant force is it produces the acceleration equal to ma. It is restoring, so minus rho GAX. So A is equal to minus x rho Ag over m. Look, density of the liquid assumed constant, G constant, tube area constant, mass constant, when this portion constant, so acceleration directly proportional to minus x, I mean when the tube is released, it oscillates up and down, and this vertical oscillation is simple harmonic. So in this way, we have to prove. Now, the actual equation for this is minus x squared. Now compare these two equation, x, x, minus, minus. So omega square is equal to rho Ga over m. So omega is equal to under root rho Ga over m, and the frequency is equal to, because omega is equal to 2 pi f, is equal to under root rho Ga over m. So f is equal to 1 over 2 pi under root rho G over A over m. So this is frequency, and then we can calculate, we can determine the time period by using t is equal to 1 over f. Okay, if the question is from this equation, derive this one. So A is equal to minus x rho Ga over m. So instead of the m, we will write this rho Al. So rho Al. So A is equal to rho cancelled, A cancelled, minus x G over L. And we have proved that G over L is omega square, so minus x omega square. Hence, from this equation, actual equation of the simple harmonic motion is proved. Now, move to the next example, which is very, very important. And this is number 5 example. Suppose we take a U-shaped tube. J-shaped or U-shaped, it's up to you. It is open at both ends. Its cross-sectional area is uniform throughout the length, and some liquid is poured into it. So this is the liquid, and the density of the liquid is rho. And the height of the liquid, one side is L. So it means this side L, this side L. So the total length of the liquid becomes 2L due to two sides of the tube. So according to the formula, mass is equal to density into volume. So the total mass of this liquid is density area into 2L. So M is equal to 2 rho AL. This 2 because two lengths, left and right. Now, here atmospheric pressure, same, 1 into 10 power 5 Pascal, 1 into 10 power 5 Pascal. So the level of the liquid in the both and it's same. But if the pressure one side increases due to high pressure here and the low pressure here, this liquid will fall. Suppose it falls to this level, and this is the fall of the liquid. It is represented by suppose x, then definitely it will rise here and it will stop here. So the rise of the liquid will also the same, because uniform tube, same fall, same rise. So from this lower level to this upper level, the total height difference, it becomes 2x. From this lower level to the higher level, it becomes 2x, and it means this is actually the liquid which is displaced. Now this side, the level is this, and this side level is more. So the displaced liquid height is 2x the double x. So what is the mass of displaced liquid? Density into volume. So density, volume is area into height, it's 2x. So the weight of the displaced liquid is equal to mg. Look, m is equal to rho a to x into g. So we can write displaced liquid weight is equal to 2x rho ag. Very, very important. I mean, the weight of the liquid which is displaced due to the high pressure at one end and low pressure at the other end. Now, when this extra pressure is released, then the weight of this displaced liquid becomes unbalanced force. So when extra pressure is released, weight of the displaced liquid becomes unbalanced force. And it will produce acceleration in the whole liquid, not only in the displaced liquid, in the whole liquid. So we can write weight of this displaced liquid is the resultant force. So the resultant force is equal to 2x rho ag, 2x rho ag. According to Newton's second law, this resultant force is ma, and this resultant is restoring, so minus 2x rho ag. So a is equal to minus x 2 rho ag over m. Now, when the pressure is released due to displaced liquid, whole liquid will oscillate up and down in the liquid. And we have to study this motion according to this equation: density constant, A constant, G constant, total mass constant, 2 constant. Hence, A directly proportional to minus X. So the oscillation of this water due to displaced liquid is simple harmonic. And when this is compared with minus x omega square, so omega square is equal to 2 rho ag over m, mean the angular speed is 2 rho a over g over m under root, and the frequency will be 1 over 2 pi under root 2 rho ag over m. So actually, this displaced liquid, which is 2x rho ag, is equal to the resultant force. It is unbalanced force. It produces acceleration in the whole liquid, and this resultant force is this. It's equal to ma minus restoring. So it's proved that it is executing simple harmonic motion. Now, if the question is, show that this is equal to this. So we can write here, A is equal to minus x 2 rho ag over m. What is m? M is the mass of the whole liquid, and m, mass of the whole liquid, is 2 rho al. So 2 rho al, 2 cancelled, rho cancelled, a cancelled. A is equal to minus x g over L, and A is equal to minus x omega square. Hence shown that it is simple harmonic motion.